In this problem, I want to find how many bags of soybeans Eric could pack. I know that this is going to be a part whole model because I wasn't given any clues that anything's being compared here. No more or twice then or 3 times. None of those hints that it's a comparison problem. I do know that he had a total of 28 kilograms of soybeans from my first sentence. Now I'll go to my second sentence, taking it line by line, filling in the information given. I'm told that he gave 3 1/5 kilograms to his wife and packed the rest equally into bags. Well, if he gave 3 1/5 to his wife, I'm going to show that on my bar model by marking off a section and labeling it 3 1/5 kilograms, that was given to his wife. It says that he packed the rest equally into bags, but I don't know how many bags he's packing yet. That's what I want to find. So I can't label anything on my bar for that just yet. I'm going to go to the next line of information that says if each bag contained 4/5 kilograms of soybeans, how many bags could he pack? Well, now I'm just looking at what's left over here. So really, I'm just going to show this by bringing it down to make it clear, but you don't have to show it with a separate bar. You can show it on the bar model here that I shaded in. So now I know that this is what's left over, this amount here. And I know that he's going to be breaking it up into bags, and each bag is going to be 4/5 kilograms. I just don't know how many bags yet. However, I can find out how much this total is, how much is being broken up into bags of 4/5 kilograms. And I can find that by subtracting 3 1/5 from 28. That's what's left over. So I'm going to do 28 minus 3 1/5 to find out what this total is here. 28 minus 3 is 25, and then I still have to take away 1/5. So to do that, I'm going to need to borrow 1 whole from 25 and write it as 24 5/5 minus 1/5, which equals 24 4/5. So now this total is 24 4/5. I want to know how many total bags I have now. I know that I have a total of 24 4/5 kilograms of soybeans, and I'm going to put 4/5 kilograms into each bag. So to find out the number of bags, I'm now going to do 24 4/5 kilograms divided by 4/5. Now, in order to solve this, we have to take our mixed number and turn that into an improper fraction. So to do that, I have to do 24 times 5, and I get 120, and I have to add the 4 in my numerator back in. So I have 124. So it equals 124 over 5. And if I'm dividing by 4/5, I change that into multiplication to solve and find the reciprocal. I can cross cancel, and I end up with 124 over 4. Now I can just divide. Remember, that fraction line literally means divided by. So 4 goes into 12 3 times, and 4 goes into 1 once. So I end up with 31. 124 divided by 4 equals 31. So that means that I'm going to end up with 31 bags. So he could pack 31 bags of soybeans. In this problem, I want to find how many pages there are in the book. So how many pages in all? This is a part whole model, so I'm going to draw my whole bar and take it line by line. Muthu reads 20 pages of a book in a day. Okay, so far I can't label anything with that information, so I'm going to hold it and go on to the next line to see if it helps me. It says, after 6 days, 2/5 of the book is still unread. Okay, so now I can look at this information and figure out how to label it. After 6 days, 2/5 of the book is still unread. 2/5 of the book. So this book, the whole book, which is what I'm wanting to find, so I'll put my question question mark there, is being split up into 5 parts. 1, 2, 3, 4, 5. 5/5 would be the entire book. After 6 days, 2/5 of the book is still unread. So 2 units are unread. This section of the bar is going to be the 6 days that he did read, right? And I can split those 3 bars into 6. So each one represents a day. But if I split each unit in half, I have to do the same thing over here for my unread section so that it's all the same. And I know from my first line that he reads 20 pages of a book in a day. Well, if each one of these bars now represents a day, and I'm told that he reads 20 pages each day, I now know what each unit is. Each one of those is 20. I can now find how many pages there are in the book. I have a total of 10 units, and each unit is 20 pages. So 20 times 10 equals 200. There are 200 pages in the book. For problem F, I want to find how many kilograms of rice would be left. Again, this is a part-whole model. I'm not given any hints that this is a comparison. I can see that it is a fraction and it's being broken up into parts. I'm going to take it line by line to begin filling in information. It says, after 1/6 of a barrel of rice was eaten, 10 kilograms of the rice was left. So, if it says after 1/6 of a barrel of rice was eaten, I know that 6/6 is the entire barrel. So I have to break this up into 6 parts. 1, 2, 3, 4, 5, 6. And we know that 1/6 was eaten, so I can label that. I'm told that after the 1/6 was eaten, 10 kilograms was left. So everything that's left over equals 10 kilograms. I want to know how many kilograms of rice would be left after 1/4 had been eaten. So now this is where it gets a little bit tricky, right? Because I know that I now have to find out what each unit is and then break the bar up into 4 parts because they want to know how many kilograms of rice would be left after 1/4 had been eaten. So let's begin by figuring out first what each unit is because we have to know what is the whole amount of rice before finding 1/4 of it. So that's our first step, finding the whole amount of rice. If I have 1, 2, 3, 4, 5 units for a total of 10 kilograms, I'll do 10 divided by 5 to find out what each unit equals. So in all, I have a total of 12 kilograms of rice. Now I can find out how many kilograms of rice would be left after 1/4 of it had been eaten. And I'm going to have to show that separately. I'm just going to draw a smaller bar to fit this in. I want to know how much would be left after 1/4 had been eaten. So I took a bar, I split it up into 4 parts because I now want to know what happens after 1/4 is eaten. I can label the whole, which is 12 kilograms. That's what I found out up here. And my question now is, what would be left over? I can use the unit method, which is 12 divided by 4, which equals 3, to figure out what each box is, to figure out that 9 kilograms would be left over. Or you could have done the fraction method, which is 3/4 times 12, where you would have cross-canceled and multiplied to have gotten the same exact answer. So 9 kilograms of rice would be left. Okay, for our last problem, I want to find how many stickers Jim had at first. Typically, when we're being asked to find how much someone had at first, it is a part-whole model because the amount someone has at first is a whole amount. So I'm going to draw a whole bar and label the whole with a question mark because I know that that's what I'm trying to find. I'm going to take it line by line to begin solving. He gave 3/8 of his stickers to Leroy and 1/4 of them to Rainey. The and indicates that I'm going to have to show both of these on the same bar. 1/4 is the same as 2/8, so I can show both of these by breaking the bar up into 8 parts. I know that Jim gave 3/8 of his stickers to Leroy, so I'm going to label 3 of them Leroy, and 2/8 to Rainey, and he had 21 stickers left. 21 divided by 3 will tell me how much is inside of each unit. If each unit is 7, and I have a total of 8 units, I can multiply them to get 56, which is the total number of stickers that there were at first.